All right, welcome everybody. Let's do this. So the second part of the homework. So we have this function, we have sine of x, and this is sine of x over here, okay? And now we have the horizontal line y equals 2. So notice that this is the x-axis, right, or y equals 0. So y equals 2, we just notice that if this is 0 and that's 4 over there, this is the line y equals 2. So let's see, where must the two graphs intersect? Okay, let's take a look at this question. Notice that we could maybe, if you want, I think something that would help you is take some colors. Let's just put this in green, okay? All right, and let's put the sine of x in purple, okay? Okay, so where must the graphs intersect? Notice that both functions are continuous, so there's no break in between. This is just a straight line, and this is a line that's like this. So notice over here, the graphs must intersect at 2. So I'm sorry, at A. What about at B? At B, could the graphs intersect? Well, let's take, you know what I should have done? I shouldn't have said sine of x. I just realized, because we know sine of x continues like this. I should have just said a function. But the idea is this graph could, let's ignore. Let's say it's not sine of x, okay? Let's just say it's just a graph. Here, notice this graph is continuous, and does it have to go through B? This one is a maybe. B should be a maybe because this graph could go like this, okay? What about C? For sure, C has to. What about letter D? Letter D, this bubble, you see the graph could go like that and hit it. So D, but it doesn't, it's not a must because it doesn't go through like this one, okay? So D is maybe. What about letter E? E is a must. What about F? F for sure, like there's no way, like this graph even goes over here, there's no way that this graph could intersect with this, and so this is a definite not. And what about letter G over here? This one will have to as well. Okay, so letter G. But now, how can we algebraically say this function intersects with this function? Like, what has to happen over here? So before, when we said we wanted to have a root, we talked about one value being greater than 0 and another value being less than 0. Okay, that's for a root. Now, for this graph, you see, this point over here, let's put it in red. This point over here and this point over here, okay? Notice that if I have this point, is this point below y equals 2? Like the y value for this point, is it below y equals 2? Yes, it is. And is this point above y equals 2? Yes. And you know it's continuous. So if you know you have a point below and a point above this line, you know it has to connect. And that's the algebraic notation, that if I have some f of x sub 1 and it's greater than 2, and f of x sub 2 is less than 2, like this is my point over here, that's greater than y equals 2. This is my point over here, that's less than y equals 2. So then I know, once I have this for anything within this region, then there must be an intersection within these points, okay? And that happens over here, like here as well. You see, when you look over here, let's look at between B and C. Here, you have a point, let's look at B over here. You have a point B, and f of, let's say this point is x sub 2. So f of x sub 2, notice that this is greater than 2. It's above that line. And let's look at this point over here, x sub 3. Notice that f of x sub 3 is also greater than 2. Notice if you have 2 points above 2 does not guarantee an intersection with y equals 2. Notice it could be an intersection. It's a maybe because you don't know if this graph goes like, you don't know within B that there's a point over here. You see, like if I had a point over there, then you know that there's a point below 2 and above 2. So then maybe this could intersect the graph, but here it doesn't. But that's the idea over here. For two graphs to intersect, you need a point above it and a point below it, or vice versa. Okay, so that's the idea for this one. Like look at letter F. If you look at letter F over here, like notice at this point and this point, they're both above y equals 2. And there's no point over here. There's no point where f of x is less than 2. There's no point below this that is less than 2. So I already know there can't be an intersection. Okay? What I want you to do is, hopefully this feels a little better. Now, let's do the next part. If you haven't done it, you can try and do letter A by yourself. For sure, like A should not be too bad. B and C is not that bad either, but what I want you to do is try and do letter A by yourself, okay? So hopefully you plotted the points, but let's plot the points. So if I have 0, 7, where is that point 0, 7? 0, 7 is 1, 2, 3, 4, 5, 6, 7. That's 0, 7. Okay, so that's 1 point. Where's the other point? 1, 3 is 1, 1, 2. I am going crazy. That is not 0, 7. I don't know what's wrong with me today. 1, 2, 3, 4, 5, 6, 7. It's been late. Sorry, everybody. Okay, so that's my point. 0, 7. Okay, where's the next point? It's 1, 3. So 1 and then 3. Okay, that's 1, 3. Then you have 2, negative 1. And then, oh wait, look. 2, negative 1. Boom. Notice, hey, what happened from this point to this point? Look what did we do before? You had to ask yourself, what? Is this point above or below the x-axis? So like this point is above the x-axis. This point is above the x-axis. This point is below the x-axis. So you know that in between these 2 points, oh my God, hold on.